And so today we are delving into one of the most exciting topics of both classical mechanics and modern physics, and that's position. And I'll definitely show you why giving the right information can be the difference between being lost and being found. Let's get. Imagine a hiker who gets lost in the middle of a city and calls for help. He's standing right here at this point P, exactly 5 kilometers east of Pilgrim Cathedral, a well-known landmark. In this situation, we can literally assume he must rely entirely on the rescuers to effectively get back home, but even more importantly, on his own abilities to guide them to his exact location. With this in mind, let's see how different hikers' responses can impact the way they interpret it and eventually get him out of this undesired situation. Okay, response number one. I'm looking at a point P. Worst blunder. This is one of the worst answers they could give. Why is that? Take this as a line representing the entire surface of the Earth. The Earth itself has countless points. By saying this, he's essentially telling the rescuers that he could be at any one of them. This is not only confusing but also completely directionless. Anyone trying to locate him based on such guidance would be utterly overwhelmed. So doesn't work at all. His actual position here doesn't line up with the rescue's viewing of his position. So we need to work a little bit more. So now let's take a look at response number two. I'm located 5 kilometers of Pilgrim Cathedral. This answer is certainly better. Rather than simply saying I'm at a point P, he has now added something else, the reference point. This is critically important since rescuers no longer have to search every single point on Earth. They only have to track this landmark and log the target. Very good. But there's a catch here. Although this is an improvement, it will interest you to know that there's still an ambiguity here. Why is that? Okay, we now have the reference point. But line itself extends into two directions. So the rescuers will still be uncertain whether to head west, east, or in some other combination of the coordinate direction. So while setting a reference point is critically important as it refines the location, it's still not enough when the direction is missing. So we need to work a little bit more here. There's still no perfect alignment between his actual position and the viewing that he gives, okay, to the rescuers. So now let's move on to response number three. I'm located 5 kilometers east of Pilgrim Cathedral. Perfect. Now he has provided the final key ingredient that was missing. Now it becomes much more practical and easy to locate him. Only what they have to do, the rescuers, is to locate the cathedral and then move 5 kilometers to the east. Perfect. Very good. So now mystery solved, lost hiker found. Okay? So making sense of it all. This spot here where lies the hiker is now precisely localizable thanks to three decisive elements. The reference point, which is the origin, the distance from the origin, and the direction. Any point in space defined by all of these three features we call position. So, defining position. Position is the specification of the location of a particle relative to a reference point using a coordinate system. What we've done so far is giving you a descriptive view of position. Now we transition into something a little bit boring for most students, which is mathematics. Why is that? It's because while words are enlightening, they are also often vague. Theoretical descriptions alone are not precise enough to deal with physical phenomena. We need to create a universal and exact language that speaks for itself. A code that anyone, anywhere, at any time can decipher and agree upon. And that's math. So what we're doing here is splitting this theoretical position here into its three components and then merge them together into a single measurable quantity. And what would be that very thing? An error, of course. Errors match perfectly because they are known to possess the starting point, they have some length, and they point somewhere. So, position here splits into origin, distance, and direction, which resembles an arrow. As you can see, it has the origin at the top, has length, and points downwards. Arrow-like things in physics and mathematics are known as vector. So anything that has some origin, a numerical value, and a direction, we call it as vector quantity. Position is a vector quantity. Why is that? It's because it meets all of these features here. And this position vector here can be shown in a simple graph like this one. First, we draw an x-axis here, place an origin here, 0, and any point A. This distance spanning from 0 to A, we call vector position. As you can see, it's an arrow here, okay? So, position vector equals OA, this distance, with an arrow here, okay? Since the absolute value from 0 to A is A, we can replace this OA with simple A here. Placing here some I hat. This I hat is a unit vector pointing in x coordinate, okay? So generalizing, we'll have this one. Position vector equals x I hat. So for the case of our lost hiker here, which is located at 5 kilometers east, we'll have this one. Position vector equals 5 kilometers I hat. So that's that, Mr. Solve. See you the next time. Hope you like what you see. Stay tuned for part 2, 2D and 3D position. Take care. Good.